Alright guys, class has started. Please take out your notebooks and work on the bell work. If you want to use the whiteboard on your desk, that's fine too. We gotta get going today. We got a lot to cover because next week we're starting trig. Today we're going over special right triangles. Alright, I want to see this in your notebooks. Chandler, wake up. What do we do? The bell work in red as usual. Yeah, we're going to finish NE1 next week. Today we are focusing on getting ready for trigonometry next week. No. We're going to get to go outside. We're going to figure out how tall El Capitan is, how tall the toes are, just by knowing how far away we are from them in the angle. I want you to show your work too. How did you figure this out?
Okay.
And I'm going to come around and check this in a moment. Alright, I should see answers by now. Some work, how to solve this. And we are on the home stretch, guys. Almost done with the school year.
It's on the time.
What are you doing?
Sitting here, wait.
Sitting here.
25. Looking good.
Did we get to school?
Other classroom. No.
Hey, hard or not all.
2.5.
You're going to need my ancient Greek friend that we talked about earlier in the week.
What's his name? Is this right? 5.
Socrates?
Oh,
no.
Not Socrates.
No, Sokato is not a Greek name, that's an acronym. We're talking about an ancient Greek is going to help us out with this problem. We talked about him earlier in the week. Not the quick lesson on trigonometry before that NE1 test. No thanks. How'd you get that?
I told you.
How'd you get that?
You're not gonna use that camera.
Okay. Well, maybe I'll show you how I got it.
All I
Maybe we could-
do is like this part goes to this part. Why is it green?
Does everyone have the lesson 8.4 in front of them too? Yes, right? All right. What was that, Zach? Everyone should see who my ancient Greek friend is with lesson 8.4. Pythagorean theorem. Pythagoras is our friend.
Jesus.
Yes. Success.
Everyone can do last day school.
We'll figure that out this last day. What do you got? Okay. Good. Yes. All right, so I'm going to give the same problem tomorrow. We got about 70% of us know how to figure this out. Tomorrow, or not tomorrow, Monday, 100% will know how to figure this out. All right. This is all about using the Pythagorean theorem.
You gonna be here tomorrow, Lee?
No. Maybe, actually. I don't know. Yeah, if you are going to Saturday school and you need some math help, you can check my room. I do have to spend a lot of time here this weekend. So Selden, how did you figure this out?
By eyeballing it.
By eyeballing it.
There's some eye measurements.
What is the Pythagorean theorem? Do you know what that is?
I forgot.
Michael, what is the Pythagorean theorem?
A squared plus B squared equals C squared.
Yes, we got in unison over here. We got a squared plus b squared equals c squared. We're going to be using this for the rest of the year. A squared plus b squared equals c squared. C always has to be the hypotenuse. Always. But that's okay. We can solve for A, B, or C using our algebra skills. So if this says these triangles are similar, they're right triangles, I know that they're similar. So I know that if I figure out this side right here, I can get the ratio of one triangle to the next with a scale factor. So if I want to figure out what C is, I know I got A squared plus B squared equals C squared. So 4 squared plus 3 squared equals C squared. We got 16 plus 9 equals C squared. 25 equals C squared.
5.
And then what do I do next?
Square root.
Take the square root, right? C squared, if I want to just figure out what just C is, take the square root of both sides. 5 equals C. There's half the battle. 5. What we're going to learn, this is a very special triangle. We're going to learn a little bit about this triangle today, and more next week. The 3, 4, 5 triangle. On Monday, I'll be able to ask you, what are these angles? Just by telling you this is 3, 4, and 5. And you'll be like, I know the answer to that, Mr. B. So if this is 5, what is my scale factor? I'm multiplying 5 times k, give me 2.5. K is 1/2. So I would say 4 times 1/2 would give me 2. 3 times 1/2 would be 1.5. All right. So on the top of this 8.4 lesson, I want you guys to write or draw a right triangle. Doesn't have to be perfect. No construction tools necessary. And label the sides A, B, and C. And next to that, I'm going to say A squared plus B squared equals C squared. And what I want you to start off with is exercises 1, 2, and 3. And I'm going to call on some people to give me answers to 1, 2, and 3. And then we're going to move on to our exploratory challenge. That's going to teach us about special triangles, special right triangles. So if you need a calculator, you can come grab one from the box over there. But I want to see answers to 1, 2, and 3. Also, one quick announcement from Mrs. Goy. Engineering and Science Day participants, please turn in your grade check ASAP to Mrs. Goy.
What does it do?
It is technically due today, but get it to them as soon as possible.
BDA is not here until Monday.
All right, if some of your teachers, like Mr. Clausen or Mr. Brigade, is not here, you can see me after class, and I'll sign off on those grades by looking up your grades online. Okay?
I don't know you.
Any other grade checks besides Ms. Goy's grade check? All right. That's Ms. Goy. I'll tell you in the class. All right, so what you should be doing now is answering exercises 1, 2, and 3. We get through this lesson quickly. You guys will have time for the homework, and you can get some makeup work done. No, the leg would be 100. All right, I got an excellent question for the first problem. 100 and 500 are the legs, it says. Would I call a hypotenuse a leg?
No.
No. So it's A is 100 or 50, B is 100 or 50. These are interchangeable. What is not interchangeable in this formula, C does not interchange with A and B. But the legs squared equal hypotenuse squared. You see this, Tim?
It's a free day.
Selden. You should put your food away. Okay? Sounds good. It's a Troy. You can put it away. Okay. You know what to do? Alright. Let's do it. Alright. If you guys want to use your iPhones as graphing calculators, that's fine. But no one is listening to music today. That's cool. Can I call somebody in?
Yeah.
Hey, Mom. Come on, answer this. Does anybody need help? We used the Pythagorean theorem before, but here we're just bringing it home, and it's going to help us identify special right triangles. You know what you're doing? Check. Good. All right, what did I say? Put that away. Thank you. What's the answer to this? Come on, solve the unit calculator.
Not
Yes, just 1, 2, and 3.
Hey, use my phone?
Yes, you may.
My water's crazy.
Get
Get it?
Yeah.
This one's B. Or this one's B.
All right, just another minute. You guys should be finishing these up.
A and B are blank. So those are.
So A.
You can leave it as a
So
square.
right here.
Yeah, B squared on the bottom. And then on top. The top is
All right, let's do number 1 together.
Look at the board.
What am I inputting into my formula for the first one?
50 times 50.
B squared.
Yeah, A and B are 50 and 100, right? So I'm going to say 50 squared
50 squared.
plus 100 squared
C squared.
equals C squared. Now, since you all don't have graphing calculators right now, you can simplify the square root. Don't have to punch it in because you're going to get a decimal probably. So, what is 50 squared?
2,500.
2,500. What is 100 squared?
10,000.
10,000. So, C squared is equal to 12,500. All right, Barton, how do I figure out what C is if I have C squared?
Yeah.
We take the square root of both sides. Yeah. Square root, square root. So really what I want you to do now is simplify the square root of 12,500. How do you simplify the square root of 12,500? Wouldn't this be the same thing?
No.
How can I rewrite that? Simplify this. Square root of 125.
What's radical?
Square root of 123.
This is what it
No, it's not. Oh, you're simplifying.
You know how to do it? No.
You break this up to 25 times 1. I want to see the work I got today. Okay.
This?
Yeah.
Because it's
All right, we have 3 problems to do.
No, you're a little over.
Alright, Troy, what does this simplify to? Square root of 12,500.
Ten times square root of 1.
Yeah, what am I doing here? I've got the square root of 125 times the square root of 100. This is 10, right? Square root of 100 is 10. So I have 10 square root of 125. We could go farther though. How can I simplify the square root of 125?
By 5.
By 5. So I'm going to have 10 times the square root of 5 times the square root of 25. Yes. So I can simplify this to 5. It's going to end up being 50 square root of 5. All right, so what? We see 2 and 3 in the same way. We're going to skip number 2, just go right to number 3.
Find your line. What will make a root? What will make triangle in here? Okay, so plus 5, 66.
We're going to skip number 2 and answer that later.
266.
Someone please think out loud.
Just imagine how everybody
Yeah,
would be.
so this one will be squared. C squared, so what we're doing when we're C for C squared, square root of x. So C equals the square root of 6,000. What you gotta do now is try to simplify that. Maybe. Simplify that. When we simplify that, say we got 50 squared. So this is the rules from the last lesson. B. If I have 1250, then I'm going to break that up into perfect squares. Square. So how can we break that up into perfect squares? Think about.
What season it is?
We're going to say 1
Where are those?
What I want to do is try to find these numbers, dividing this number by.
I'm just kidding.
Right now, it's just breaking it up. Try to find 15, so try to find this in fraction. Yeah. Okay. No. Top there.
Alright, when I plug these in, what are we trying to figure out with number 3? A, B, or C? C, right? And this is what we're figuring out. So Natani, what is A squared
Number 1.
for number 3?
225.
225? 75 squared. So what is 225 squared? Dylan, help him out. What is 225 squared? 75 squared? And then I'm taking the square root here. So what we're really doing here is we're trying to simplify the square root 56,250. How does that work out? Yeah, I've got two numbers here that I know they're divisible by. Guys, please pay attention. Before we were looking at 144, 121, etc., trying to find out which perfect squares can we take out of this number here. But I know right now that this number is divisible by 75, most likely, because I'm adding from 225. And 225, so I'm going to try to divide this by 225. What do you get? What do you get when you divide 56,250? 250. So here we've got 225 times 250. Is it also divisible by 75?
Yeah.
Brittany? Brendan, yeah? So what do I get? So I have this, or I could say it's the square root of 75 times 750. Which one of these can we get to a smaller number? This makes it a little bit more doable here. Instead of trying to figure out which one of my perfect squares I'm working with this number. All four of these numbers are divisible by 25. Yeah.
Try to figure out 5600 divided by 25.
We have put the calculator doesn't have the infinity sign. I put the calculator doesn't have the infinity sign.
What would you use the infinity symbol for?
See what the square root is.
Square root of infinity would be infinity. Let's stay focused here. So the more realistic question is, 225 divided by 25 is what? What should I think of that?
Should be 9. And 25, that'd be 10. Oh, smart.
Do that?
Huh?
You say 3 times 25,
330.
25. Ways to break this down.
They're both 90 square root.
Sheldon, please don't talk unless I ask you a question, okay? The other people are trying to figure this out too. All right, we've got to move on here. So, Mortiz, what did you get for when you compute these together? How can you shrink this down the smallest? Tell me, see, can you help them out? Well, we'll break this one down first here. So we got 9. I can pull these out. 5 times 5. What I'm left with is 9 and 10, right? We could go even further, right? This would simplify to 25 square root of 9 times the square root of 10. We know what the square root of 9 is, right? Square root of 9 is 3. So I would say it's 25 times 3 times the square root of 10. Square root of 10 we can't do anything with. So what the final answer should be would be 75 square root of 10. And next week we'll work a little more with these because I think we don't have a great handle on this. So we're going to, that's what bell work is most likely going to be on Monday. This can be kind of confusing when we deal with huge numbers. That's why we had lessons on dealing with square root numbers and how to simplify them earlier in the week. I know you guys have been NEWA testing. All right, so what I want you to do now is move on to number 4. We got. We got number 4. Alright, so while you guys are working on that, I'm going to write it on the board. I'm going to point at the overhead projector today.
Number 8, yes.
Is this your stuff from?
Yeah, I was looking for that. Thank you.
It's right there.
Oh, thanks.
Yeah. Okay.
Wait, this would be what? It's B. I just write down one.
All right, everyone should be working on number 4 right now.
I can get number 3 already.
Equal arrow triangle aside the length
It is this is the ground first. I close. I saw it coming. I got it.